without further ado, I think Gabe, you can turn your camera on and unmute and do all that stuff, and I'll turn over screen sharing to you. And welcome.
Hi, thank you so much. I am so excited to be here. So thank you, Derek, and thank you to the folks organizing Shy Hack Night for the invitation. Um, Alrighty. That is not what I want. Okay. Derek, can I get a thumbs up if that looks like the right set of slides? Okay,
Yeah, looks correct to me.
fantastic. Great. Well, thanks again, everybody, for being here. My name is Gabe Morrison, and I'm a data scientist at the Urban Institute. So this evening, I'll be talking a little bit about Urban's Spatial Equity Data Tool and about its new API that we've launched in the last few months. But before I do that, I want to talk a little bit about me. So I'm actually no stranger to Chicago. I went to the University of Chicago for undergrad, where I studied geography, which I think, as you'll see, there's like kind of a clear through line thinking about urban issues and resource access and patterns across space. So that's kind of where I first started about thinking about those things. And they definitely carry through to the spatial equity data tool. I also got a master's through a joint program at the Harris School of Public Policy, and then also through UChicago's computer science department. So there's a picture of me a couple years ago, very happy celebrating that I had finished that program. Since then, I have left Chicago and come to DC, where I work at Urban. And one of the projects that I've worked on the longest is this spatial equity data tool. So really excited to be able to share it with you all tonight. I've worked on a little bit of a lot of other things like synthetic data generation, as well as kind of just a lot of different data projects. That's, a little bit more about me and kind of where I'm coming from and why I'm here tonight. So with that, I can give you a little bit of an agenda. So at least for this presentation, this is what I'll be talking about. First, I'll introduce you all to the spatial equity data tool. Then I'll talk a little bit more about the API, kind of what it is, why we built it, kind of potential use cases for it. I'll also talk about some new analysis features that we have wrapped into kind of the tool as we developed the API. Then I'll talk about kind of how to use the API. And then I'll talk about next steps, both in terms of what we're doing on the urban side in terms of development of the tool, and then potentially for you all, how you can kind of use the tool as well. So that's where we're going. And then we'll have plenty of time for questions. So I'm excited to chat about those as well. Okay, so with that, let's talk about the spatial equity data tool. So the first question is kind of, what is the spatial equity data tool and how does it work? So at its core, I think the spatial equity data tool can be understood with this kind of flow chart. So the tool takes point spatial data or anything that you could plot as a set of points on a map. So we think the tool is particularly effective at looking at kind of resources or services or amenities that kind of governments or other organizations could provide. But anything that's like a point on a map, that would work great. So for example, in Chicago, you could look at the Divvy bike stations, or you could look at the location of park, the location of bus stops. You could look at COVID testing clinics. Those are all kind of very, very, I think, logical applications of the tool. So we have that data, which is the point spatial data, and then you can upload that to the tool. The tool will then spend some time kind of analyzing and processing that data. And then the tool will return to you a demographic disparity score and a geographic disparity score. So that leads to the question, what are those scores? Okay, so first, this is the demographic disparity score in kind of a chart showing what it looks like. So the demographic disparity score answers the question, across the geography of the data you're looking at as a whole, what are the demographics of the census tracts where your data come from? And how do those demographics compare to that geography as a whole? So that's kind of like a little bit of a jargony formal definition. So I can kind of show by example what that means in this use case. So this is a screenshot from our tool. And the data we've uploaded here is from New Orleans, and it is their 311 call request data. So if we look at the top line, what that line shows is that the census tracts where these 311 call requests come from have a higher level of white non-Latinx residents relative to New Orleans as a whole. And conversely, you can see that line on the bottom. What it's saying is kind of the census tracts where 311 call requests are coming from. Those census tracts have like disproportionately low numbers of non-Latinx Black residents compared to the city of New Orleans as a whole. So again, this demographic disparity score, we're looking across our geography. So in this case, we're looking across New Orleans and trying to understand which demographic groups are over or underrepresented in their access to the tool. Okay, so that's the demographic disparity score. We also have the geographic disparity score. So the geographic disparity score has a little bit of a different approach. It looks at specifically a subgeography. So for this, for the city level, we are looking at the census tract. So it says, what it specifically does is it compares the proportion of your data points that are uploaded versus the proportion of a baseline population. So in this case, the total population. And the geographic disparity score is actually just the difference in those proportions. So if we say for a given census tract, if the proportion of points is greater than the proportion of the population, it would have a positive disparity score, and we might describe that census tract as being overrepresented by those resources. And then conversely, if a census tract has a lower proportion of data points than the proportion of the population, we would say that that census tract is underrepresented by those points, and it has that negative disparity score. So you can kind of see in the map, right? You can see these blue tracts slightly overrepresented, the orange tracts slightly underrepresented. So that's the geographic disparity score. One question you might have is, okay, where is all this data coming from? So again, you have that point resource data set and you've uploaded that. So that data can come from, wherever you want, wherever you can find point spatial data. Maybe your organization collects it. Maybe it's from an open data portal. I don't know. But then the population data sets that we're comparing against, those are all from the American Community Survey. So just like 5-year ACS estimates. So that's the second data source. Okay, so we've talked about the demographic disparity score and the geographic disparity score. Now there might be a question, okay, how might you use the tool? So kind of this first line is what I was saying before. You could use the tool to measure equity in terms of the allocation of place-based programs. So if you're interested in playgrounds or bus shelters or libraries, how equitable is the distribution of those programs or those resources compared to, the baseline population you think is most appropriate. You could also use the tool to examine the representativeness of program participants relative to a target population. So in this kind of use case, suppose you have the locations where program participants live, right? You could compare those locations against a baseline population of the kind of the universe of the population you're hoping to target with that program. I think a really promising area for the tool is identifying areas for future investment. So you could look especially at that geographic disparity score. You could find areas on the map that show kind of underrepresentation. And that could be a sign that would be an area that is in need of investment for the resource you have uploaded. And then lastly, you could use this tool to inform department priorities and measure progress towards equity goals. So I think what we have in mind here is, in theory, right, suppose you have data over your program over time. You could, upload 1 year of data, see where kind of a program has responded or where you've invested resources. Then the next year you could see kind of like the new updated data, and you could see how the patterns change both with the geographic and the demographic disparity scores. And you could see how those equity scores change, just like it's saying. Okay, so that is really quickly kind of a high-level introduction to the tool. All right, so with that, I am going to brave Zoom and in window switching and show you guys what this kind of looks like in practice using our website tool. And I hope So yes, here we go. All right. Okay. All right, perfect. So you can see this is just like Chrome, nothing exciting going on here. So you can just search Spatial with the data tool, right? And then this gets us to the tool. You can also find data to download. So, I think kind of the example that's most apropos here and very much a callback to my time at UChicago would be using the Chicago data portal, which is a really rich data source. I'm sure if you're watching this, you're quite familiar with. But right, you can just go to the Chicago data portal from the city of Chicago. The example I was looking at before this is parks, right? So this is Chicago Park District. You can see that these are points. I don't actually know why the points are disappearing here, but you can see that this is a point data set, right? Before it briefly goes away. You can export this. Notably, our tool takes CSV or comma separated values. So you need to kind of get data as a CSV. Okay, you can see I maybe download this once or twice before. Then we can go back to our tool. Because we're analyzing the data at the city scale, or because we have city data, we want to choose the city level here. Our tool can handle data at these other scales too, though. So we have nation, state, county, and city level data. So, and then when I was talking about like the subgeography that sometimes changes across the different scales. Okay, so we can say upload our own data. Boom. We can drag it here. Okay, fantastic. Always a dangerous thing here for GIS folks. This is a classic thing I always get backwards, but you can click run analysis. So the tool is receiving the data, kind of it will then like run some analysis, right? Boom, we've processed 4,400 rows. And then it's wrapping up. Okay, huzzah, it has now run. And we get outputs that look just like the screenshots. But now we have the Chicago example. So really excitingly here, we get these results. I like that when you hover, you get this interpretation, right? So you can say across Chicago, your data, so in this case, the point park locations come from neighborhoods that on average have 10.4% more residents in this demographic group than the city as a whole. So we can see that kind of interpretation here. You can download the data as a CSV, and you can download the chart. And then we have a map as well. Just one thing to point out, I think you can see kind of the results here are, I guess it's a little bit hard to know what to make of this. It looks kind of not like a super obvious pattern, at least at my first glance, but you can see some of these very high overrepresentations are census tracts that are actually parks. So you can see here, this is actually Humboldt Park itself. So we see that if you see on the left side, there's 1.3% of the data points here, but 0% of the population, which kind of makes sense because it's a park. And then I think this is a hospital, right? So we do that subtraction, 1.3% of the data points, 0% of the population, we say it's 1.3% overrepresented. So this is kind of an intuitive result. Okay, so that's the last thing I want to show here is just we have a link to our documentation right here. And I'll be talking more a little bit about that in a little bit. But that is what I wanted to show with our web tool. So I will shift back to the slides. Okay, fantastic. So we have now done the live demo. Okay, so here is this question, like how do you interact with the tool? And the model I just showed you is kind of what this chart is hopefully representing, right? Where a user can go to the tool, and then the tool uploads data kind of, and we have some AWS, Amazon Web Services infrastructure on the back end that runs the calculations. It returns the data to the website, which then shows that those analyses to you. But so really excitingly, as we have mentioned at the top, we also now have an API. So this is a second mode of interaction with the tool, which we're really excited about. So not only could a programmer interact with the tool, but also you could have kind of pieces of software themselves. And I'll talk a little bit more about that in a little bit. Okay, so with that, I want to shift gears and talk a little bit more about our API, which we launched this spring. So to start, I think we have this question, what's a motivation for our API? And we think we have power users, or we have power users who use the spatial equity data tool. But one piece of feedback kind of working with different folks who've used the tool is like that they want to embed the spatial equity data tool within their own tools and data workflows. And as you saw, the tool is really user-friendly, right? You can just drag and drop, and it's interactive on the website. But that's not a way you could like embed spatial equity data tool calculations into some other process, or it would be difficult. But with an API, that's a much more helpful or a much more easy way to kind of embed those calculations. Also, as I mentioned before, kind of in the process of updating the code base for an API, we incorporated some advanced analytical features. So stay tuned. I'll share about those in just a little bit. And then lastly, a key ethos that we have with the tool, and I think is part of the kind of reproducible open source software in general, is just that we want the tool to be free and open source, and the API continues to be. So that's really exciting. Okay, so with that, how might you use the API? So as I kind of said, you could potentially build a custom dashboard or some other tool that incorporates the spatial equity data tool through its API to your dashboard. And I won't describe it in depth now, but we have worked closely with one city to kind of do exactly that. So this is definitely a real life example. You could also, we've not yet done this, but we think this could be an exciting application of incorporating the spatial equity data tool into an open data portal, right? So like potentially you could envision the city of Chicago like showing those kind of disparity scores with point spatial data on a data portal. I don't know how like plausible that is, but that could be a way it could be incorporated. And then lastly, we could envision a use case where kind of programmers or data analysts could interact with the spatial equity data tool with more user-friendly tools, by calling the API. So if you wanted to call the API for, maybe 10 different analyses, it would be easier to do that with an API as opposed to just kind of going on the tool and manually uploading and downloading the data set. So it could be a good use case for kind of change over time data, right? If you have like 10 years of data, again, it would just be easier. Okay, so those are potential use cases for the API. Now just zooming out a bit, API stands for Application Programming Interface. The way we engage with the API is we have URLs that we kind of expose to the public. And these are called endpoints. So what are our endpoints for the API? We have 3. So first we have and each endpoint is associated with what we view as like a step of using the tool. So first we have this upload user file endpoint, which you use to make a request to the spatial equity data tool. So it's very akin to kind of uploading data on the tool website where you say, hey, spatial equity data tool, please analyze this data. So if that runs successfully, you get a kind of a job ID code. And then step 2 is you can use that code and ask the spatial equity data tool API, hey, have you finished running my request? What's its status? And then lastly, we have a get output data endpoint, which returns the results once the spatial equity data tool has finished running. So that's kind of the 3-step process of using the API. If you want to learn more, we have a Data at Urban blog post. So Data at Urban is the Urban Institute's kind of like more technical blog. And so you can go there and read more about our API and a little bit kind of on some behind the scenes of like what we changed and how the pieces fit together. So that is our API. Okay. Now I want to talk a little bit about our new analysis features. So we have 2. The first is we have updated built-in comparison data. So as I was saying before, right, we're comparing the uploaded point resource data set that a user gives to American Community Survey data. The tool originally used 2015 to 2019 American Community Survey data. Now the website uses 2018 to 2022 5-year ACS data. So that is kind of more up to date. So that's good. Our API, we're really excited to say, uses or has the option to use 2015 to 2019, 2017 to 2021, and then 2018 to 2022 ACS data. So we think that's favorable because you can kind of pick the 5-year ACS data that is most appropriate to compare against your data. So for example, if you had data that really comes from the range 2015 to 2019, perhaps you would want to use that set of data as opposed to the 2018 to 2022 data. So that is very exciting as well. Okay, so that's kind of feature number one. Feature number two is supplemental comparison data. So this is a screenshot of the tool and the geographic disparity scores. The way we've been describing, or the way I've been describing this tool is, so for the geographic disparity scores, we're saying you upload and then you get your points, and then you compare the proportion of those points against a baseline population. What this chart is showing is these are the baseline populations you can compare against in the web version of the tool. So for example, suppose you're interested in distributing like Wi-Fi hotspots, right? It might be really appropriate to use population without internet access. That being said, we think these, there's 7 baseline data sets here, and we think that covers a lot of use cases, but we definitely recognize that this is not the sum total of all kind of populations you would want to compare the distribution of your data against. So the supplemental comparison data feature allows you to, using the API, upload census tract population data, and then it will incorporate that population data as a baseline in the analysis. And so you can do this separately. You can upload data both for the geographic disparity scores, and then separately you can upload it for the demographic disparity scores. So we think that's really exciting as well. Okay, so that is the 2 kind of cool new features that have come along with the API. So now we want to talk a little bit about how to use the API. One thing we haven't quite mentioned yet is that we have a setter R package. So a spatial equity data tool R package. So the package itself is kind of a set of wrapper functions that wrap around each of those endpoints. And then we have kind of an even bigger wrapper function that wraps around each of those functions. So you can actually interact with the tool using one function in R. So I think that makes it pretty smooth to call the spatial equity data tool with that. We also have some functions that create kind of not as elegant, but some more some visualizations in our native software that look similar to the kind of the geographic disparity score map, the choropleth map, and then the lollipop plots of the demographic disparity score. So that's helpful as like hey, I got my results. This is kind of now in our data frame or an SF data frame. How do I actually make sense of it? Those functions are a good place to start. Okay. The second thing, this is kind of what I alluded to before, is we now have public documentation in the form of a Quarto book. So you can get to that just with where I highlighted on the website page. So we have chapters talking about a lot of things. So, an overview, we go step by step. If you're curious, like what does the tool do on the back end? So we have kind of like the algorithm of what it does. We have a lot of things in there, but the thing I most want to draw attention to is we have a chapter on the API. So we have example code in Python that calls the API, and then we have example code in R that uses the setter package that also calls the API. So that's a good place to start if you're like, all right, I'm ready to use the API. That chapter is where you should check out. Okay. So with that, there's a couple kind of things we want to share. First, we're open to collaboration. So if you have questions about the tool or kind of a use case, you should definitely let us know. We have a spatial equity data tool at Urban, or SEDT at Urban email that I, along with my colleagues who help build the tool, look at. So, definitely send us an email there. I also responded to my first GitHub issue on Setter via GitHub last week, so that was very exciting. So, you can get a hold of us a couple different ways. So I alluded to this too. So coming soon on our end, we have kind of 2 things that we're working on right now with respect to the spatial equity data tool as a whole. The first is a resource library. So what you should expect to see coming from us is likely in our documentation page, we're going to have a series of case studies that show a mix of text kind of describing a potential use case for the tool. So saying, hey, here's a data set. This is the type of question the tool could answer. And here's like it in a kind of more policy, applied context. Plus we'll have code, so potentially in Python, potentially in R. Yeah, likely those two, that kind of run the analyses. And yeah, and we'll just give kind of guidance on maybe rules of thumb on how to use the tool and how to interpret the results even more than we have now. So that's thing number one, the resource library. Thing number two is a new distance-based access measure. So I kind of hand waved over this, but what we're working on this other exciting feature too. So what we're doing is currently the way the tool works is it treats access in a very specific way. So we say currently when we upload points to the tool, we say that the people who have access to a point are only the residents of the census tract where that point is located. So that's like called kind of maybe this container method, right? So if the census tract contains the point, they have access to it. If you don't live in that census tract, people aren't treated as having access to that point. As we all know, that's not how people move across space. So, like census tracts are kind of like imaginary boundaries, right? You can like walk through a census tract boundary and you don't know it. And we all do this every day. So what we're trying to do is add a second way to measure access. So kind of the approach we're taking is saying, hey, if you look at a census tract, what if instead of saying just in the census tract boundaries, we'll instead say what's like a reasonable travel time. So we haven't figured out the exact definitions, but we think we'll be using kind of a walk shed approach and then separately a drive shed approach. So for example, you might be able to choose like, hey, I want to know if from the center of the census tract, if I can walk to within 15 minutes and get a resource, we might say that's what access is. Or maybe on the other hand, you could say if I can drive to it within half an hour, we view that as accessible. So that's the type of change in access we're hoping to incorporate. So stay tuned for our next steps on that work. Okay, so lastly, these are kind of the next steps for you. This is the documentation link, and you can also get it where I showed you just on the tool. Again, definitely reach out to us if you have questions, if you're interested in learning about the API, and stay tuned for updates as we are excited to kind of launch those things near the end of this year and in 2025. Okay, so with that is the presentation. I am going to turn it kind of over to you all for questions.
Excellent. Thanks, Gabe. Lots of information. I certainly have a lot of questions myself that I can ask. But for folks on the live stream, go ahead and type your questions right into the chat, and we will make sure to get to them in the order in which they're asked. I'll go ahead and start it off with just kind of curious, like what was the kind of impetus or the like original use case that you had like to go make this tool?
Okay, that's a great question. In full transparency, I cannot speak to the creation of the tool as that was kind of before my time. That being said, I can say this was developed starting in 2020. So as you all know, with the killing of George Floyd, there was an increased interest in measuring equity and in our case, spatial equity. So I think my colleagues did kind of a landscape scan and understood really to our knowledge, there's not another tool like this that gives kind of spatial equity metrics. So I think that kind of helped fuel the initial creation of the tool.
That makes sense. And actually, I mean, I've worked on tools that are sort of similar in some ways to this, but not quite done in the same way you've done. Obviously, it's like a very like sort of broad. The fact that you could upload sort of arbitrary data to it is really special. It's like a hard thing to accomplish. So I can definitely see some use cases for it, for sure. And on that vein, I'm kind of curious, in your using of the tool or other people using the tool, what's like the worst performing, the least equitable data set you've ever seen?
The worst performing and the least equitable data set. That's a really good question. So I think maybe those are two different questions, and I feel more
Okay.
comfortable tackling the first.
Yeah, sure.
But the worst performing is the tool doesn't do very well when there's like only a few data points. So you can
Sure.
imagine some resources like hospitals, for example, where maybe there's like 10 hospitals in Chicago. It's like there's definitely not a hospital in every point or in every census tract. So we're just going to have little islands of like slight over and under representation. So
Hmm.
currently the tool kind of struggles with that type of data set, even though, right, like, hospital access is really important. I think in terms of, I'm not sure I have a great example. I think the example we show with New Orleans is like pretty stark in terms of like disparity scores, just in that like, oh, everybody has about the same access, but if you're white, you definitely are in areas that have more 311 calls, and if you're black, you're in areas that have less 311 calls. That's pretty stark, and I think that's kind of compelling in why we use it in the slides. But I
Yeah.
can't say that's like the most disparate. Yeah, so that maybe is a cop out, but that might be where I'd go.
Oh, fair enough. And yeah, the 3-1 data, I'm not sure if you tried it in Chicago, but I have seen some analyses done of like calls for service, like and 3-1 analysis in Chicago, and I think you would very likely find a similar disparity in that. So it probably is an indication of like just the segregation in these cities generally. It's a way to like observe that in this, in this case 311, right? Yeah, I guess as far as question from the audience, actually, yes, Michael had a similar question about any use cases you've seen that have been especially interesting to you, just while we're on the topic of, yeah, data you've seen people use this tool on.
Yeah, so I maybe have two responses to that. So kind of on a serious note, the use case I kind of hinted at but haven't really talked about is that we've collaborated really closely with a department in the city of Los Angeles that's in kind of the chief administrative officer's office. And they do kind of equity performance management. So they are kind of incorporating the tool into a budget process. So, city departments can use the tool to identify areas potentially where they would hope to, invest resources in the next budget cycle to, target disparities. So that is awesome. That's, a super, super great, I think, use case of the tool. And, we're really excited about it. And they've been awesome partners for us. So, and actually kind of not to shamelessly plug, but the shameless plug here is we did a webinar in March, and they presented kind of more in detail on their presentation. So I'm happy to share that link out to you all. But
That's
so I think that's a great kind of impactful use case in the like policy sense, like, hey, let's actually use this fairly. Kind of on the meme side, we saw one use case. This was also before my time, but somebody figured out how to use like a McDonald's API to figure out which, like, I think McFlurries or some kind of ice cream wasn't working. And then so like they pinged all the APIs, they figure out the locations where there's like broken machines, and then they use the tool to kind of analyze the equity in the broken
Oh,
ice cream
dang. So
machine.
they made the McFlurry desert map, is what you're
So
saying.
yeah, it was nationwide, but like so it was something like that. I might have to check my notes for exactly, but it was like McDonald's sneakily using their API. So
Yeah.
that was a kind of crazy example when I heard about it, which is also notable.
Yeah, that's great. Another question from the chat from Elena. Does this tool calculate spatial equity for every individual demographic variable? And then a second follow-up question, how can different inequities, crime versus internet access, for example, be compared with each other?
So those are really good questions. The first question is we definitely don't. As I was saying, we have that one slide where the geographic disparity score, we have I think 7 baselines. So you can kind of compare your points against those 7. And then the demographic disparity score, I don't know exactly how many, it's somewhere between like a dozen and 2 dozen variables. So we have a good amount in the tool, but this is like the exact reason we built the API and that option to upload kind of supplemental data. So if there's like a group that is in the American Community Survey, right, you can just pull that data. Or, if you from some other source, like maybe you have kind of your own data, or it's from a local level, you can upload that to the tool and analyze it yourself. So we kind of view that as a big shift in I think the ability to use the tool. The other question, how can you use it to kind of compare different types of disparity scores or different types of data? I think so. One thing that like is a choice, at least when I present the tool I do, is the examples I give are what I would like call amenities, right? All the things we talked about, having more parks, that's probably good. The Divvy bike share stations, that's good. 311 call requests, like the city's responding to you. But you can have point data for any data, and you can have it for disamenities too. So for anything like that, if you have kind of like arrest data, for example, and you have the coordinates, you could look at that. But then areas that are overrepresented, maybe that has like an alternate interpretation where the blue is like, oh, that's, there's disproportionately high arrests here compared to a baseline population. So that could be a really interesting and compelling use of the tool too, even when it's like the blue is like not maybe the quote unquote good thing. So I think that's one thing to note. The second thing is, so kind of the tool itself doesn't let you, like, you can't upload two data sets at the same time. You would have to upload one and then another. So there is that limitation. If you are a programmer or a data analyst, you definitely though could, either using the web version of the tool or the API, upload the two different data sets. And then you could, particularly for the geographic disparity scores, you could do an analysis where you say, hey, what are my census tracts that are overrepresented with this one measure, and then what are overrepresented or underrepresented with the other, and then potentially you could target the tracks that like meet the criteria. It's like, hey, a concern from this data set and a concern from that data set. So that's actually kind of some logic we use with LA. So I think that's a reasonable use of the tool as well.
Yeah, that makes sense. I think it also that seems to be the case where creating some kind of index, right, where you're bringing in multiple variables to sort of create one number to represent sort of all the things you care about as another way to do that, because multiple variable mapping is treacherous.
That's an excellent point. So actually, to be most specific, that's exactly what our LA colleagues do.
Okay,
Their office has created an index that they call an equity index, and
I see.
it takes like, I think, 16 variables together. And then like the logic they use is say, hey, what are areas that are either over or underrepresented? And then what are also areas that have high need based on our equity score?
Yeah, okay, makes sense. Great. Question from Steve. How accurate do you believe the ACS data maps are at the local level versus state or national?
So, I think, this is like not a statistical answer, but I think fairly accurate. We have really good documentation on our statistical significance calculations, if you're interested. And we do kind of test that. So you'll notice in the tool, right, the areas that are kind of gray, either in the map or the kind of the lines that have like a gray circle at the end, there is a like mathematically a difference in the estimates, but we have conducted the statistical significance calculation and deemed it not statistically significant. So from that respect, we follow the ACS's guidance on how to use their data to calculate those calculations. So from that perspective, I think it's pretty good. I think you'll notice for some variables, right? Like population under 18, because those are smaller counts, they just have like more noise in them. So you'll find less groups have like, or you'll find less like areas are statistically significantly over or underrepresented.
Yeah, that makes sense. Yeah, with small sample size.
Exactly.
Question from Steve Kleinschmidt. Do you plan on using spatial interpolation to generate heat maps within the web app?
So I would say no. I don't think that is like maybe a next step for us, but I definitely, if you think that's a compelling use case or you see an example where we should, send us an email, and I'm definitely interested, or if like this is something you do, you should totally, we'd encourage you to do it, and we'd love to hear about it.
And then another question from Michael, is it possible to have different geographic areas other than census tracts? For example, in Chicago, ward is another like geography people care about.
Yeah, that's a really good question. So no, our kind of, we have all our data, as I was talking about, is from the ACS.
Yeah.
And it's hard for us to, because a strength of the tool is it's flexible nationwide, right? So we have different
Mhm.
scales, and we have, everywhere in the US it works. But as a consequence of that, um, we don't have that level of flexibility. That being said, our code is open source. So if you think the right level is the word, um, I think, our code could be a starting point to do kind of spatial equity data tool-esque calculations.
Mhm. Yeah.
Um, but yeah, that's a great question. And we have thought a lot about kind of these different geographies, or like, what if you did not one county, but you want to do a multi-county area? Those are definitely questions we're asking, and are on our radar.
Yeah, for sure. And actually that's actually kind of work that I've done some before. And actually there's a tool that DataMate has that we inherited from the Sunlight Foundation, actually. That's the
Mhm.
census wrapper that allows you to take an arbitrary geography and then it stitches together the census tracts within it so that you can get like census data at sort of an arbitrary geography. And that's an open source tool. So like something like that, potentially could be stitched together with your tool using the API if someone wanted to do it themselves.
Yeah, that sounds awesome. We'll definitely have to look into that earlier, or afterwards.
Yeah, for sure. So another question, let's see, I have a few that I wrote down. We have about 10 minutes left here. Um, so you talked a little bit about the impact. You mentioned that I think you mentioned it was a municipality was using this tool to help with some of their decision making. Do you have other examples of like the use of the tool and the impact it's had? Has it sort of helped shape policy? Has it helped sort of convince folks that, oh, this needs to be, this asset needs to be built here or that kind of thing?
Yeah, so we've had discussions with a lot of folks. We've talked to a researcher in Georgia who's kind of planning on incorporating the tool. So like, that's on an academic side. We've definitely kind of through LA talked to different departments and shared the tool with them. And like, I think there's been interest in those departments and kind of incorporating it into their budgets. That's building off that example. We know of like other use cases too. Like, I think a nonprofit in Marin County used it to look at, I want to say, I don't exactly remember, but I know they looked at it and like took away results there. I've talked to somebody who looked at school closures to try to understand kind of before and after school closure, how are we serving kind of elementary school children.
Mhm.
So I think our best example, at least in my mind, is the Los Angeles example, but there are definitely other use cases.
Mhm.
And also, I would just say, like, we have ongoing kind of discussions with a number of folks. So hopefully with that resource library, we'll have like kind of established those relationships and then documented that more formally than kind of this
Mhm.
response.
Yeah, yeah, makes sense. And actually, I had mentioned the Sunlight Foundation. I'm not sure if you've heard of them before,
Mhm.
but looking at the site, and just hearing you talk about it, it sounds like you all built this tool at the Urban Institute internally with like internal staff. Is that right?
That's right.
And that seems like that's something that's maybe a little bit unique to at least folks in the sort of like policy space, right? And like the Sunlight Foundation is no longer active, but like they were in a similar vein. They were all about open government and good governance and open data, and they had developers on staff that built tools so people could actually use those things. So it's just cool to hear about an organization that has that capacity. I'm just kind of curious, just if you could speak a little bit more about that, like how big is that team? I imagine you have a lot of different tools you're working on. Has that been part of the practice of the Urban Institute for a while, or is it something that's more recent that you've built out that capacity?
Okay, that's a great question. Definitely an opportunity to shamelessly plug Urban. But so just on the Sunlight Foundation, my supervisor, Elena Stern, who has kind of been around working at this tool since kind of its inception. Also, used to work at the Sunlight Foundation. So I think,
Yeah,
I don't want to speak for her, but it feels kind of consistent.
like a through line. Yeah,
Yeah.
for sure.
So that's kind of the one thing to say. Uh, we have a data science team at Urban, and then we have a sister team that is kind of has data engineers and software engineers. And then we also have a data visualization team. So I would say this has kind of been a collaboration. And the data visualization team is very technical, and they do like front end web stuff. So this has been a collaboration from the three of those teams. So uh, the data science team, we did a lot of the AWS stuff on the back end and kind of the calculations themselves. And then our data software engineering folks helped us with the kind of continuous integration, continuous deployment. And then it's a Django API. So they set up that API, and that was a huge contribution that I'm very grateful that they helped us with. And then lastly, our data viz folks uh, worked on the like the interactive nature of the website. So from that perspective, this is like definitely in-house capability that we have. I, I think, you'll see on the Urban website, there's like a lot of, I think data viz is the most like forward facing of us. So they also have kind of interactive charts that do data visualization and stuff like this. So yeah, I guess my kind of summary is we definitely have this capacity. I don't know if we have like another tool that kind of combines all of those teams in an externally facing way like this. That being said, if you're on this call and are like, hey, we need something, you can shoot us an email too.
Awesome. That's great to hear. Another question from the chat from Sebastian. I know your organization is called the Urban Institute, but do you see any use for applying this tool to more rural areas?
Yeah, that's a great question. So definitely in the conversations we're having about the kind of distance-based measure is absolutely something uh that we're thinking about in the rural context because like census tracts are often designed based on like a population estimate, but because rural places are rural by definition, those census tracts are large. So that's something we're definitely thinking about, and like that's why we want kind of a drive time of maybe a larger time, like an hour. So maybe in a city that doesn't seem like a reasonable way to measure access, but in the country it might really be a reasonable thing to say. So I think just in general we're thinking about rural things. um, and I definitely think so, right? Like, you can use this at the county scale for rural counties or in states that don't have large cities. And I think it will still have meaningful analysis. And then again, just with that, like the drive time calculations, I think those analyses will be even stronger in a few
Mhm.
months.
Yeah, absolutely. Yeah. So the more rural you get, the more people are typically driving, longer distances, right? Just to do just the things they need to do to live. So that makes a lot of sense. Let's see. I think we probably have time for one last question. So one actually, another tool that kind of came to my mind, especially when you were talking about the ACS data and looking at like the variables that you all make available. There's a tool called Census Reporter. Have you heard of
Mm.
that before? It was funded by the Knight Foundation. Jojo Muska, Chicago-based is based in Northwestern. I think maintains it now. Essentially, it's like a wrapper on top of like the ACS data, and you can like kind of search for a place, search for a table, and like, boy, there are like lots of tables in the ACS. So I just wondered if you've heard about it, and then thinking about maybe there's a possibility that that tool could be helpful for helping you all help like make those different ACS variables available to do your analysis. If you did, for example, want to show show me the internet access, right, and like make my analysis based on that ACS data.
Yeah, that's a really good question. I feel like I've kind of just seen this, and when I'm trying to hunt down an ACS variable, this has like come up and often been the answer. I can't say I've used it kind of extensively though. But that's a really good point and definitely a flag for us to look into more.
Awesome. Yeah. And that's one of the great things about the fact you have an open source tool and an open API. It makes chaining these things together. You don't have to build the Uber everything app, right? You can do your piece really well, and then these other pieces you can sort of stitch together, and that has a like really powerful kind of aggregation kind of effect that I think a lot of people could benefit from.
Totally.
Yeah. Well, excellent. I think, yeah, we are at time. So, yeah, I just want to say thanks again, Gabe, for presenting. This is a really exciting tool. For those of you watching, if you're going to be joining the second part of Hack Night, I think we'll be starting that in just a moment here. Gabe and I will be joining that call in a minute. I should probably put up the slide just so you can see where to go. This is the slide. Here we go. So yes, go to bit.ly CHN remote Zoom. We'll drop a link in the chat as well. And we will be starting that call probably in just a moment here. But thanks again, Gabe, and thanks again, everyone, for watching. We will end our live stream with our famous catchphrase.